right, so where's the,
Yeah.
okay.
Mesdames et messieurs, Seth.
Okay, this looks promising. Almost there. Okay, I kind of gave away my first slide. Okay. Hey, everyone. Really thrilled to be here. Thank you for having me. Yeah, as I said, my name is Seth. I've been with Amazon for several years. I actually joined in 2005, so if you're doing the math, 13 years doesn't work out. I left for a little while, went to Microsoft. And being there since 2005, before AWS was even launched, I've worked with lots of teams across Amazon on how they develop software for large scale and reliability and how they adopt AWS. And that's how I learn. I learn through example. I learn by you show me how someone else has done something, and that kind of makes the concept real to me. So that's why I created this talk. It's about how Amazon is doing DevOps in the cloud. And if you were here yesterday for Sasha's talk, you already saw the wall, right? So the wall is something a lot of us in DevOps understand and know about. It's the wall between developers and operation. And it's not just a wall that prevents us from seeing each other and communicating with each other. It's a wall that prevents us from having common objectives, common goals. Developers want to release stuff and get stuff out there. Operations wants it to be stable. Those can be in conflict. So a lot about DevOps is about breaking down that wall and sharing common goals. Now, there's lots of different ways to do this. There's no one, fix-all solution. There's lots of different organizations you organize your teams around. Sometimes they're called topologies. You've probably heard of that. And I'm going to share with you the one that Amazon uses. But I don't want you to think it's the only one. But it's the one that Amazon uses. And that is, you build it, you run it. I'm a big fan of you build it, you run it. All right, so you build it, you run it means there's a single team out there, and that team has an on-call rotation because whatever they build is in production, and if there's something wrong with it, they're responsible for fixing it. That's a genuine Amazon pager. Most folks these days are using the Pager app, but there's still a few of those genuine pagers out there. And you have a single team that owns everything from the design to the code to the deployment to the operation and production. And so that single team at Amazon is something we call the two-pizza team. So you'll see 2PT, that's two-pizza team. That's a team of size that could be fed with approximately 2 pizzas. You've probably heard that. It's an old Amazon thing that's been around forever. So it's really the two-pizza team that builds it and runs it. But the two-pizza team is really a core part of Amazon culture because it's not just about them building and running. It's about ownership, tight ownership. So a two-pizza team can own one or more services, and they're responsible for those services, decisions ranging from what features go into that service, to what technology they're going to use to build that service, to how they're going to run that service and when it gets deployed. And they have fairly broad autonomy. Now, they do work within guardrails, and we're going to talk a little bit about those, like guardrails around security and resiliency and things that they have to do. So they're not free just to do anything. But within those guardrails, they do have pretty broad autonomy. And if you heard me say that team has decisions over what features go into their service, you might be thinking, that's kind of weird. Why do a bunch of developers get to pick the features? Well, in some cases, if it's an internal product that's being used by other development teams, then that might actually just be just right there. The developers understand what other developers need. But if it ends up being part of an external-facing service, like how can developers do that? Well, it's not just developers. A two-pizza team is multidisciplinary. It includes product folks, developers, QA, UX designers, et cetera. Not always under the same manager. Sometimes it's a V team, but it's all that multidisciplinary team working together in close cooperation on the common goals. Now, everything I've said up to this point is culture, and you should know that DevOps starts with culture, and really that that can't be emphasized enough. If anybody starts talking about tools with forgetting about culture, then they're off base, right? You got to start with culture, and the tools derive from that. So everything I've said so far is culture, but you do have to make it happen, right? You have to, like, this is something I'm telling you how Amazon does it. You might want to try it yourself. You have to figure out how to make it happen. And if you're thinking, you're probably pretty suspicious right now, or pretty skeptical right now, right? Because you're thinking, I don't want my team having to reinvent the wheel. I don't want each of my teams having to figure out how to set up a deployment pipeline, or which deployment pipeline to set up, or how to set up observability, or even how to set up an escalation path, like I showed you the pager. I don't want each team having to figure that out themselves. I don't want each team reinventing the wheel. And I agree with you. So therefore, I'm going to share with you through the rest of this talk how you avoid that, what we call undifferentiated heavy lifting. And undifferentiated heavy lifting is the stuff you have to do, but doesn't add value to the end customer. And I'm going to focus on tools and frameworks, but not just tools and frameworks. That seems kind of obvious. If you provide the proper tools and frameworks, you can reduce that undifferentiated heavy lifting, and the teams could spend more time on developing for the end customer. But you notice the first word there is teams. It has to be a tool that's owned. It has to be a tool that you can rely on and go to the owners of that tool when you need help with it or when it's not working right. So it has to be an owned tool. And that could be, and Amazon, that's another two-pizza team. So instead of a two-pizza team developing an end-user product, it's a two-pizza team developing and owning an internal tool. And then they don't have to develop your own. You could certainly use lots of the sponsors talked about great tools that they're offering here today. Use those tools if you can. I'm just going to share at Amazon, we tend to develop our own because of two reasons. One is Amazon's kind of old. It's been around for a while. So some of these tools were developed before third-party options existed. And the other thing is that Amazon is huge. And at the scale of Amazon, sometimes the third-party tools don't meet our needs. So we develop our own. But we do use third-party tools, and even when we do, there's still an internal team that has ownership over that tool, so that you're not just using it's not like each two-pizza team at Amazon's using this tool independently. They have someone who internally they can go to and say, hey, it's not meeting our needs. And then you end up with the architecture of what Amazon looks like today. This is the modern architecture of Amazon. Each dot on there is a service, with the lines between them being the lines of dependency between the services. And there's tens of thousands of them. And I look at that, and this is just, to be clear, the Amazon side, not AWS. We're going to talk about AWS. Amazon is a customer of AWS, but this is Amazon. And it includes the store and Alexa and Prime Video and all that. But I look at this and I say, this can't possibly work. This is going to fall down tomorrow. This is going to blow up tomorrow. There's no way this is viable. But it's kind of fractal in a way. As I said, each two-pizza team has tight ownership of one or more of those dots. And that each two-pizza team is operating within an organization of multiple teams that are communicating with each other, and within a department that's with organizations communicating with each other. So it keeps rolling up and up so that it actually does work. And as promised, I'm going to share some specific examples of how this is applied. So this is example number one. This is what we call a detail page on Amazon. This is where you go to buy stuff. I think most of you in this room have probably found yourself on a page like this. It's got everything you need. It's got the image. It's got the price. It's got the buy button. These are all very important things. But that page is created by multiple teams, by hundreds of teams. And how's that possible? Because there's a framework. There's a single team called the buyer experience team that creates and owns the framework for this detail page, so that other teams can create the back-end services that this page calls. This page makes hundreds of calls in parallel to these hundreds of services to populate that page. And this is what it looks like. This is using an internal debugging tool. You can see there's an image service. There's a title service, there's a pricing service, there's an average rating service. So it's making these calls to hundreds of different services to render that page. And this has two big advantages. Number one is agility. Each service can deploy and make updates independently. And again, there are guardrails in place. What the big rule is for any widget that's called widgets, any widget you add to the detail page or make a change to your widget, there's number one rule. That number one rule is it must not add latency. Zero added latency. So there are guardrails in place. So you can deploy independently as long as you're not adding latency. But the number two thing, and this is a talk about reliability and resilience also, is something called graceful degradation. I'm going to keep coming back to this. Graceful degradation says, rather than go down when one or two or three of these services fail, I'd rather offer my users an availability experience that they can still do what they need to do, but maybe in a gracefully degraded state. So for instance, if you couldn't see the average ratings, or you couldn't see the Amazon's Choice badge, you might not be too broken up about that. You might still, and you'll still be able to make your purchase. service. Now, there are some critical services like the price or the buy button that are absolutely critical, but most of these are not critical, so you could still operate in a gracefully degraded state, and that's a way to maintain availability and be resilient for your customers. Example number 2, another way, the way you often get to the detail page is through Amazon search, right? So I'm going to search for chaos engineering, and for no particular reason, right? I think you'll find out why in a moment. And when I search for chaos engineering, I get back, thousands of results here. Search is a large-scale system, right? All these systems are large-scale systems. It served over 84,000 requests per second at its peak on Prime Day a couple of years ago. Now, chaos engineering, who here has heard of chaos engineering? Okay. Yeah, most of you. All right, I'm still going to tell you what it is, though. You can't get to go around it. And what it is was defined in this book here, which then that definition was rolled into the principles of chaos, which you see the link to there. It says, discipline of experimenting on a system in order to build confidence in that system's capability to withstand the turbulent conditions in production. What does that mean? It means we're going to actually simulate failures that we might see in production in a scientific way in controlled experiments to understand the impact of those failures and ensure that we're resilient to them. It's not about creating chaos. The chaos in chaos engineering is not about the chaos you create. It's about the chaos that exists out there already, right, in production, and you are making yourself stronger against it. So I want to introduce you to a two-pizza team called the Search Resilience Team. This is a two-pizza team of engineers, of developers that consider themselves to be an operational excellence organization within the search org. They're serving, there's over 40 back-end services that go into search. And I don't know how many two-pizza teams that is, but it's probably a couple dozen. Well, the Search Resilience Team is serving those teams. And it's serving as an owner, remember I talked about that ownership, of the platforms and tools that, some of the platforms and tools that those teams use. So they drive the resilience of Amazon Search Services, that's their mandate, and we're going to look into how they enabled the teams in search to adopt chaos engineering. And to do, if you're running a service on AWS, there's lots of different chaos engineering frameworks out there. There's a Chaos Toolkit, there's a few, that's open source, there's a few commercial ones. I won't name any just so it doesn't look like I'm endorsing anybody, but there's lots of commercial ones out there. There also is, if you're running on AWS, the Fault Injection Service, or FIS. This is relatively new, it's a couple of years old. So if you're running on AWS, it's worth looking at FIS. And this is an example of Amazon, as a customer of AWS, using a third-party tool, the third party in this case being AWS, when they're looking at chaos engineering. So it seems like a good place to start, so this is where they started. And FIS allows you to define targets, like am I targeting a server, am I targeting a network port, what am I targeting, and define actions. Am I going to take down the server, am I going to black hole the network port, what am I going to do? But that third box there, guardrails, safety controls and guardrails. If you don't have guardrails in place when you're chaos engineering, you're not doing chaos engineering, you're just injecting failures, you're just creating chaos. The guardrails are metrics, objective metrics, that you're measuring during the experiment to see if the experiment's going off the rails or about to fail, so that you can roll it back. So you need those guardrails in place. Now, the team wants to do these kinds of experiments. So using FIS, they want to kill an EC2 instance. They want to drain a container drain a node of the containers using their container deployment. They want to inject latency and a bunch of other things. But they also want to do other experiments that FIS doesn't do, like load testing or emergency levers. Now, emergency lever is an internal Amazon term. So I'll explain what an emergency lever is in a bit. So this is the requirements they came up with as the search resilience team to be able to get all of those 40 search services using chaos engineering. Number one is it was going to be centered around FIS, but it also needed to be able to do these other kind of experiments. The other thing is they wanted to provide a graphical UX and API. Now, obviously, FIS already has that, but this is a search-specific one. This would show all the search teams and the search services and their chaos engineering status, and provide an API for those teams to onboard. They want to be able to run on a specific schedule. Now, when they created this requirement, FIS had the ability to do that, but it required some work. So they figured search resilience team figured they would do it for them. Now FIS supports this natively. They want to be able to run as part of their pipeline. Again, FIS can do this, but you have to sort of stitch it together yourself. And also, Amazon uses a proprietary pipeline framework internally. As I said, build your own tools. The pipeline framework goes way back, right? So in order to make it easy for search teams, they did the integration. They wanted to have the guardrails in place. Remember I mentioned the guardrails? Using SLOs, or service level objectives. Now, this is important. Now, as a resilience team, they already set up an internal framework for every team to define one or more SLOs, or service level objectives, that are their critical metrics. So already having this in place and having those SLOs already in a system meant when they created this new system for doing chaos engineering, they could just integrate them and just take those SLOs and use those as guardrails. And on cord, that's the ability to pull a cord in a factory and stop the line if you see a quality issue. Same thing here. Anybody in search can press a button and stop all chaos experiments. And rolling up metrics and insights. Of course, you can do this natively with the FIS product, but this is specific to search teams and showing the search metrics. And this is what they built. If you look to the right side, far right side of this diagram, that's the back-end search services, those orange boxes. Then you can see FIS is sort of at the center there. The left box, that whole left side, is the chaos orchestrator. This is where the search resilience team built an orchestration service around FIS to be able to meet all those requirements I showed you on the previous slide. You can see there's a run API, there's an andon API, there's a scheduler with DynamoDB and a Lambda running there. So they created the system. This is what they created. And this enabled all the teams across search to onboard and do chaos engineering. And of course, from our resilience point of view, having this kind of continuous evaluation as part of every deployment is a real benefit. Now, I promised I'd explain to you what emergency levers are. So emergency levers are these actions you can take when things are starting to go sideways, when things are starting to go bad. These are actions you can take to help the system recover or maintain availability. So in search's case, it looks like this. This is a typical search page. This is what you search for Lego. You get all this great, rich experience. But if search is about to go down, they're starting to see some of their services brown out, they could pull the emergency lever and it's graceful degradation all over again. Turn off some of the back-end services and deliver just the critical experiences, the image, the title, the price, so that you as a user can still get value out of this search page. So, and the emergency lever is not something they invented. That's yet another internal framework that's enabling teams to do more. They onboard onto the emergency lever framework, and they're able to implement these emergency levers. Okay, our third example for the day is the Amazon Relay app. This is an app that you could install from the App Store on iOS or on Android onto your phone right now. Now, unless you're a long-haul trucker, the app's not going to do much for you. Who here is a long-haul trucker? Anybody? No? Darn. Yeah, I got one taker. All right, so you install the app and let us know how it goes after you get in your big rig and deliver various boxes of widgets. So that's, you see these big trucks all over, right? I mean, I assume folks have seen these big trucks. These are not the trucks delivering stuff to your doorstep. These are the trucks delivering stuff from the vendor to the warehouse or between the warehouses, something we call middle mile. Delivering stuff to your doorstep is called last mile. See how that works? So this is middle mile. And this is an app used by the truckers that tells them where to go, when to go there, how to get into the fulfillment center. That's what that code is. It actually scans and they get them in the fulfillment center, what to pick up and where to take it. So this is, think about it this way. The logic behind how Amazon balances where its stuff is between hundreds of fulfillment centers across the North American continent is a very sophisticated computer model. But until you actually get that model to do something, to tell a trucker to go here and move this stuff from here to there, it's worthless. So this is the manifestation of that complex model made real. And this is the design. If you look where the arrow's pointing, those are the back-end services. There's about a dozen back-end services. They call them modules, so I'll call them modules. And what they're pretty easy to envision what they are. There's a module that generates the gate pass. There's a module that tells the trucker what load to pick up and where to pick it up. There's a module that gives the trucker directions. There's a module that lets the trucker chat with dispatch. And all of these modules are owned by different two-pizza teams. And in front of those is a single API that is built on AWS that is routing those requests from the app to the correct module. It's also doing some authentication stuff you can see there too. So this architecture itself is a framework, right? We're talking about frameworks. So like if you're a team that was looking to build a new module for the app, this is a framework that they put together where there's a well-defined relationship between the gateway and the modules. As long as you follow that relationship, you could build an app or build a feature for the app. So now they wanted to improve their resilience, so they decided, in their case, it made sense to go multi-region. A region is a place where AWS has several different data centers, multiple data centers in a specific part of the world that host AWS services. So there's one in East US and there's one in the West US, and they were only in the East, and they figured by going to the West, they can improve resilience. Now, do you need to go multi-region to improve resilience? Probably not. Like most services can meet their resilience needs in a single region, but at the very high levels of ultra resilience, going multi-region can help. And this is what it looks like. This is a single back-end module, right? It's simplified. There might be other stuff going on, but it's showing a Lambda, which is serverless compute. It's showing DynamoDB, which is serverless NoSQL database. And it's showing how you could replicate that service between the East region and the West region. It's about deploying the code to the Lambda in both regions. And then there's a feature, part of DynamoDB, called global tables that automatically replicates data across tables in different regions. So by doing this, a given module is able to adopt a multi-region posture. However, not all modules needed to do this. Like, especially since they wanted to move quickly, they had to decide which were the critical modules and which were the less critical ones. So critical ones would go multi-region. That would be like stuff like the module that tells the trucker where to go and what to pick up, or generates the gate pass. And less critical modules, one that maybe generates directions, you can get those directions from any app, right, might not go multi-region. So it ends up looking like this. You see module A has gone multi-region, that's the one on the top, and module B has not gone multi-region. And the gateway has also gone multi-region, so the gateway exists in 2 regions. So that if you're a trucker in the East, your request is probably going to go to the East gateway and to the East version of these services, and you're going to get pretty low latency. And similarly, if you're a trucker in the West, it's going to go to the West gateway and the West version of these services. This is called an active-active architecture. Both regions are actively serving requests, depending on where you're located. But this also gives you the ability for higher resilience, because if you determine as a service owner that there's a reason that you can't operate in the East region anymore, there's maybe a service event going on that's impacting your ability to operate there, you can fail over. You could pull a switch and turn off the East gateway. All requests go to the West gateway. So in that case, for module A, it goes to a back-end service in the West region. All is good, right? But for module B, what's going to happen? It's still going to go to the East region because module B hasn't gone multi-region. That's interesting. What's going to happen there? Well, it'll either work because you failed out of the East region. Doesn't mean the region's hard down. I mean, that doesn't happen. Regions don't go hard down. You failed out of the region because maybe there was some latency there, or there's a specific service that was down there or something. So that East region still might work, or it might not. And if it doesn't, we're back to graceful degradation, right? I'm able to generate my gate pass, go pick up my load, but I don't get GPS directions, and that's fine. And taking this back to that concept of frameworks and tools and teams, there's a centralized builder tool teams at Amazon. And each of these boxes you see on the screen is a separate AWS account deployed by a separate pipeline with separate code base and separate packages going into that pipeline. And that's enabled through builder tools. Builder Tools creates the systems for internal Amazon teams to spin up accounts, deploy infrastructure, deploy code, create pipelines, deploy those pipelines. So everything I said before about being independent and resilient, add to that now this ability to fail over for resilience. And just as an example of one of those frameworks internally, this is, in DevOps, we're very big on infrastructure as code. Infrastructure should always be code. So in AWS, you could use CloudFormation, or you could use CDK, which is infrastructure as code using real languages. And internally at Amazon, they have this repository of templates. So you're a service team spinning up a new service, and you need to deploy a VPC, as everybody does. That's a virtual private cloud. You grab this template. Or if you need to deploy an RDS instance, you grab that template. And these templates have been vetted by both security, for security best practices, and also for well-architected best practices. So well-architected best practices are the canonical best practices that AWS publishes for deploying in the cloud. So this is another example of an internal framework that helps internal teams, removes that undifferentiated heavy lifting, lets them get to deployment quicker. And that's it. So there's multiple two-pizza teams across Amazon being enabled by teams that own tools and frameworks. I shared with you the buyer experience, the search resilience, and builder tools teams, but there are many, many more across Amazon, all enabling these two-pizza teams to both build and run their services, own everything from the coding to the operation in production. These are some resources you might be interested in if you want to learn more about the stories I shared. The top 2 ones are blogs about the search chaos engineering, and also about the Relay app. And the bottom 2 are videos that you can check out. One is from reInvent that I gave on these services. So with that, I have time for some questions. Oh, thank you. Okay, I see someone. Is someone here with a question? Oh, there.
So, yeah, sorry. Can you share a little bit about how you control the latency of the detail page?
How do you control the latency? That's not something I'm expert in. Basically, it's making calls in parallel, right? So when you add a new widget, you're not adding serial latency. So I guess the point there is, and this is really, my knowledge is really limited here, is that your latency for your individual widget has to be less than all the other widgets, basically. I can't go any deeper on that because I don't know.
Hey there.
Hi.
Amazing talk.
Sure.
Question. So Google has SRE, right?
Yeah.
Meta has production engineering.
Yeah.
What does Amazon have for operational-minded?
Yeah, we have the leadership principles. In longer talks, I talk about how the leadership principles are really DevOps. So we have leadership principles of customer obsession. Any DevOps person will recognize that as we're always focusing on value for the customer. We have a leadership principle of ownership. I talked about how tight ownership is part of our culture. That's the visionary part, and we talk about that all the time. Functionally, it's what I showed you. You build it, you run it, supported by teams, tools, and frameworks.
Awesome. Thank you.
Sure.
Really great talk. Thanks a lot.
Thank you.
Curious for the teams building those internal tools, how do they kind of advertise their tools or features or changes and also get feedback from users? Is that also standardized?
Yeah, they get lots of feedback, and they get it directly. I mean, like, there's Slack and there's email, and what they'll do is they'll generally set up office hours. So at a fixed time or a couple of times, like because we're a global company, you can come into the office hours and ask questions and give feedback then, so that they're not being barraged with Slacks and emails. But it's also at different levels, right? Builder tools is company-wide, including Amazon, including AWS. Everybody's using them. So they have such a huge user base, they have to have that more formalized kind of office hours type approach. Search Resilience team is serving a couple of dozen teams in search that they work very closely with. So they can maybe have a less formalized version. They could be meeting with those teams. They could probably meet with every team in search and get feedback that way, or get requirements that way before they go off and build something.
Yeah, I was wondering about the video game division. Do they use the same kind of patterns, or do they differ a lot?
I'm not sure. I don't work too much with the video game division. I will say, and I've said this sometimes when I talk about this topic, there are always exceptions, by the way. I should have said that right at the beginning, right? So if you go meet someone who works for Amazon, and they say, no, we have an operations team, and they're doing great. Yeah, that exists. It does. It's not the general rule. The general rule is you build it you run it. So how the games divisions work, I don't have the details on, but they could be an exception, or they could be using this, or they could be a mixture of both. It's all about that ownership and autonomy. They get to decide as a department, as an organization, and then as teams within that organization.
Thanks.
All right, we'll maybe take another last question.
All right, last question.
Seth will be around for questions, so.
Thank you. My question's around the two pizza teams. Specifically, you said it was multidisciplinary.
Yeah.
Some of those people, I assume, are less technical. Are they also still responsible for when there's service degradation, repair, all that?
Oh, who's carrying the pager?
Yeah.
As always, it depends on the team. I got to imagine that product managers are generally not carrying the pager, but there might be a team out there that does, and they can actually triage stuff and get it to the right developer. But it's generally going to be, developers or other technical people. Like there are teams where the QA folks will carry the pager. Matter of fact, QA folks are really good at carrying the pager because they often understand the end-to-end system really well. So they might not be able to code a fix, but they could certainly put out the fire. So yeah, it depends. And we actually had an internal discussion that was kind of funny, I'll share it, about principal engineers. Like principal engineers are kind of put up on a pedestal, right? And the agreement generally was, no, get your butt into the rotation. You're not special. Yeah.
Thank you very much, Seth.
All right, sure.